Hello，大家好，我是 Andrew. Today is day 3 of my English speaking project. Today I'm going to talk about algorithms, inspired by this great book, Algorithms to Live By. Um, a lot of people think about algorithms in terms of ways to solve computer problems. But actually, it's way broader than that. It's a procedure of like a procedures or a serial a sequence of steps that solves any problems in life. For example, today we're going to talk about the optimal stopping problem. Stopping problem can be applied to hiring for candidates, deciding when to quit your job, when to sell your house, or when to fall in love with, when to find someone to date or someone to marry to. So, having a strategy is really important. And the strategy we're using is optimal solving problem to find the optimal time to stop and jump decision. For example, if you want to hire the best candidate in a group of people you're hiring, and once you interview this candidate, you either need to give him an offer or pass. And once you decide to pass, of course, you can't hire him anymore. And once you to hire someone, you can't interview anyone after this guy. So the problem comes, there's two scenarios you might fail. One is to hire too quickly, and one is to hire too late. So how do you come up with a strategy to hire for the best? If there's only one person coming coming for the interview, of course you need to hire him because there's 100% that you're going to hire for the best. If there's two people, regardless of whether you choose the first or the second, it will always be 50%. When there's three people, you choose by randomly, you will pick the with a 33% of chance. But if you come up with a strategy, no matter what happens, you give up the first candidate. And if the second candidate is the best, is better than the first, then you hire him. If he's worse than the first, you hire the third guy. Amazingly, you get a 50% chance, 16% higher than hiring randomly. Why? Let's say let's label the best to the worst by 1, 2, 3. You'll hire, so there's 6 combinations. 3 times 2 times 1. And the chances you hire the best will be 2, 1, 3, 3, 1, 2, or 2, 3, 1. So you actually get there will be 3 times you hire the best out of 6. This also comes if you want to find someone to be your girlfriend or someone to get married. These strategy all applies. Like you search for a while without considering, not committed really to anything, and then you jump. But in this book, it says a mathematician actually execute this strategy, but he didn't consider the fact that he might get refused. So when he get to the exact person he wants to marry to, he proposed, but he actually got refused. Also, this tells us there's other dimensions that we need to consider about optimal stopping problem. Also, you need to think about how you're gonna decide what is the best. If you hire for a candidate, you can create a test or whatever to score them, but in a lot of cases you can't really do that. Also, you need to take into consideration the cost of going through more people. In some cases, it's not too substantial, but in some cases, the cost of going through one and another option is substantial. Okay, so to wrap up, optimal stopping problem is really interesting because once you stop, you can't move forward, and it's basically the way that you can't go back and you can only move forward and you can only pick once. It's like life. You can only live once, and the time that passed by you can never retrieve it back again. So it's a really interesting problem. I know it's a little bit academic, but hope it's interesting as well. Hope you enjoy day 3 of our English speaking projects. I'm looking forward for the next video. I hope to be a little bit more interesting, and that's all. See you tomorrow. Have a good night. I hope you like my towel and my doll here. Okay, bye.